Hi everyone, today we are discussing compound inequalities, which is where we take two inequalities and combine them into one. So we have inequalities that have and inequalities that have or. If we see an and, it means that the graph is between the points. If we see an or, it means the graph is going in opposite directions. So the first example is x greater than 2 and x less than 6. You can see because they are less than or greater than, the 2 and the 6 both have open circles. And because we have an and, the area between the 2 and the 6 is what is shaded. So that means that any values between 2 and 6, but not including 2 and 6, are a solution to the graph. So in other words, 3 would be a valid solution, 4, 4.5, 5, because they are all within this shaded area. Okay, another way to write and is just to put x in the middle or whatever variable you have. So you have your far left number, your far right number, and then the x goes in the middle. So it is between. Okay, so in example 2 here, the only difference is when you put the equals on your operators. You can see now that we have closed circles. Okay, so that is the only difference between 1 and 2. Okay, on example 3, notice that the and has changed to or. In or, the graph will go in opposite directions. I could be in one area or the other. So 2, once again, is an open circle, and x is less than 2, so the arrow points to the left. 6 is an open circle. X is greater than 6, so we shade to the right. I could, for my solution, be either in this left shaded region or I could be in the right shaded region. All right, for the last one, the only difference between examples 3 and 4 is we have actually included the equal portion, so our circles are now shaded. So let's try several different examples. The first example is where we have our inequality all written in one line. There are no words of and or in our inequality. So our steps is we're going to keep this as one equation. We're going to undo the addition or subtraction for all three sections. Then we're going to solve and graph. So we have 4 less than or equal to x plus 2 less than 8. Okay, I want to get x by itself, so that means I would need to subtract 2. Because there are 3 distinct areas, I have to subtract 2 from all 3 sections. And when I do that, 4 minus 2 is 2. The less than or equal comes down, the x comes down, and 8 minus 2 is 6. Okay, and now we will want to graph that. So here on our graph, you would see that 2 is a solid circle because of the equal bar, 6 is the open circle, and the x is in the middle in between 2 and 6, and that is where we shaded. Okay, so this represents all real numbers greater than or equal to 2 and all real numbers less than 6. Okay, so let's try a different one. This time they have the word and. So based on my original, I know and means that the variable ends up in the middle. All right, so we have 2 different equations. We're going to keep those 2 equations, and we are still going to undo our addition, subtraction, and then still solve. So the first thing we're going to do is undo the addition and subtraction for each of these inequalities. In the first one, I need to subtract 3 from both sides, giving me -8 is less than or equal to 2x. In the right side, I have to add 2. That gives me 3x is less than 9. Okay, now we just need to divide. So on the left, I'm dividing by 2. On the right, I divide by 3. So I now have -4 is less than or equal to x, and I also have x is less than 3. Now it had the word and, so I know that my answer, the variable x, is between these two numbers. So when I go to graph, try to move these out of the way. Okay, I'm just going to slide them up. Okay, when we go to graph, okay, we have -4, we have +3. 3 is open because this should not be an underline. Okay, and here we graph in the middle. So this is what our inequality answer would look like. -4 less than or equal to x less than 3. Okay. Now, when they have or, we said that it's going to go in two different directions. Okay, so step 1, we're going to keep those equations as two different directions, two different equations. We're going to undo addition, subtraction, solve, and graph. So in the left, I want to subtract 4. And in the right, I am still going to subtract 4. Okay. So in my left equation, I end up with a greater than 5, and in my right equation, I end up with a less than 1. Okay, now we know they're going in opposite directions, so I'm going to find the 5 and find the 1. They're both open circles because there's no equal portion. A is greater than 5, all the numbers greater than 5, so the arrow is to the right. A is less than 1, all the numbers smaller than 1, arrow is to the left. Okay, so this could have been written as A greater than 5 or A less than 1. Okay, all right, one more. Once again, we have an or, so we're going to keep them separate. We know we need to get rid of this 2, so we'll add 2, and we need to get rid of that 1, we will add 1. And when I do that, I have r is less than 2, and r is greater than 5. So on my graph, I find 2, I find 5. There's no equal pieces, so they are both open circles. Less than going to the left, greater than going to the right, and it would be written as r less than 2 or r greater than 5. You have to put the word or. Okay? So if we just wanted to write the inequality for this graph, we have the -8, it is less than or equal. So x is less than or equal to -8, or, because it's going in two different directions, x greater than 0. And here we have all the numbers between -9 and -2, so we would say -9 is less than x less than -2. Or we could have said -9 is less than x and x is less than -2. So remember, ands shaded in between, ors go in opposite directions.